Swartz theorem आणि यंग theorem. पहिल्याने आपण बघणार आहोत Swartz theorem. If fy exists in a certain neighborhood of a point AB of its domain and fyx is continuous at AB, then fxy at AB is equal to fyx at AB. So by mean value theorem of f of x defined on the interval a to a plus h. Now here f of x is continuous on a to a plus h. F of x is derivable on open interval a to a plus h. Then there exists theta belongs to open interval 0 1, that is 0 less than theta less than 1, such that f of a plus h minus f of h is equal to h into f dash of a plus theta h. Now we have to prove f of xy at AB is equal to f of yx at AB. Define a function capital F of hk is equal to f of a plus h b plus k minus f of a plus hb minus f of a b plus k plus f of ab. Now we can take the first two terms in one bracket and second two term in one bracket. Define this capital G of x is nothing but f of x b plus k minus f of x b, and capital F of, therefore f of hk becomes, this first two terms becomes g of a plus h. If you take g of a plus h, if you take replace this x by a plus h, then this um, function becomes f of, if we here we replace a plus h, so f of a plus h comma b plus k, that is this term, and minus f of a plus h b, that is this term, that is this is nothing but g of a plus h. Similarly this term is nothing but g of a, so capital F of hk is nothing but a g of a plus h minus g of a. Now this given function g is continuous on closed interval a to a plus h, also it is derivable on a to a plus h. Therefore uh, what is the derivative of this g of x with respect to x? That is the partial derivative with respect to x, that is fx x b plus k minus fx x b. Now by Lagrange's mean value theorem, there exists 0 less than theta less than 1, such that f of h k is equal to h into g dash of a plus theta h. Therefore, f of hk, put the value of g dash of x is nothing but this. Just replace here x by a plus theta h. Therefore, it becomes f of hk is equal to h into fx a plus theta h, comma b plus k minus fx a plus theta h b. Now let second function capital H of y is equal to fx a plus theta h y. Now therefore f of hk is equal to h into capital H of b plus k minus h of b. Now here this function f of h of y is also continuous on this interval closed interval b to b plus k. Also it is derivable on open interval b to b plus k. Therefore also we can use the LMVT for h of y. Therefore there exists theta dash such that 0 less than theta dash less than 1, such that f of hk is equal to h into k h dash of b plus theta dash k. Just replace this b plus theta dash k here. So it becomes f of a plus h b plus, now here this is nothing but f of hk, value of f of hk is f of a plus hb plus k minus f of a plus hb minus f of a b plus k minus f of ab is equal to hk fyx a plus theta h b plus theta dash k. Now this hk, टेक दिस एच के इन लेफ्ट हँड साइड, हा इकडे मल्टिप्लायला इकडे येताना तो डिवाइडला होईल. एफ ऑफ ए प्लस एच बी प्लस के मायनस एफ ऑफ ए प्लस एच बी डिवायडेड बाय एच के मायनस एफ ऑफ ए बी प्लस के मायनस एफ ऑफ ए बी डिवायडेड बाय एच के. इकडे राहील एफ ऑफ yx a plus theta h b plus theta dash k. Now we can take 1 upon h as a common and just take the k as in denominator, k as in denominator. Now take k tends to 0 from both sides. If you take k tends to 0, therefore this limit becomes, take the limit k tends to 0, limit k tends to 0. Now this limit is nothing but fy of a plus hb, fy of ab, and limit of this is nothing but k tends to 0 जर आपण k टाकला, k is equal to 0 टाकला तर काय मिळेल f by x a plus theta h b. Now this is 1 upon h. No, this is divided by h. Fy of a plus h b minus fy of a plus b, f of a b divided by s. Sorry, this is not in multiply. This is divided by h fyx. Now take the limit as h tends to 0 from both sides. Limit h tends to 0, fy of a plus h b minus fy of a b divided by h. Limit h tends to 0, fyx of a plus h b. Now here fxy ab is equal to, now this limit is nothing but fxy ab, and here the if we put h is equal to 0, then it becomes fyx at ab. So here we show that fxy at ab is equal to fyx at AB. Now this is the proof of Swartz theorem. Now second important theorem is Young's theorem. Statement of Young's theorem. If fx and fy both are the differentiable at a point AB of its domain of xy, f of xy, then fxy at AB is equal to fyx at AB. Similarly, as above, define the function f of hk. We have defined in above f of hk. Just here replace k is also h. So f of hh is nothing but f of a plus h b plus h minus f of a plus h b minus f of a b plus h plus f of b. Also, as above, take g of x is nothing but fx b plus h minus fx b. So f of hh is nothing but g of a plus h g of a. Since fx is exists at ab, g of x is derivable on open interval a to a plus h. So by using Lagrange's mean value theorem, there exists theta such that 0 less than theta less than 1, such that f of hh is equal to h into g dash of a plus theta h, h into, what is the g dash of x? G of x is nothing but h into fx a plus theta h b plus h minus fh a plus theta h b. Here we can h into fx a plus theta h b plus h, fx a b minus fx a plus theta h b plus fx a b. Here we can add and subtract fx a b. Here subtract fx a b and add fx a b. Now consider these two brackets. In the first bracket these two terms, in the second bracket in these two terms. Since fx is differentiable function, therefore this increment in the function fx a plus theta h b plus h minus fx ab is equal to, can be written as theta h fxx ab plus h into fyx ab plus theta h phi 1 of hh plus h into psi 1 of hs, where phi 1 and psi 1 are the functions tending to 0 as hk tends to 0. Again, the fx is differentiable, so this becomes fx a plus theta hb minus fx ab is equal to theta h fxx ab plus theta h phi 2 hh, where phi 2 is again function tending to 0 as h tends to 0. Therefore, equation 2 becomes f of hh is equal to h into theta h fxx ab plus h into fyx ab plus theta h phi 1 hh plus h into psi 1 hh minus theta h fxx ab theta h phi 2 of hh. Now here we can take h on left hand side, so f of hh divided by h, and also we can take h as a common from whole terms. Here is there is h, here there is h, here there is h, here there is h. We can take h as a common, so we can take h square as a common and take this h square in left hand side. So f of hh divided by h square, we get fyx b plus theta into phi 1 hh plus psi 1 hh plus minus theta into phi 2 hh. This is equation number 5. Now put h of y is equal to f of a plus h y minus f of a y. We can show that similarly we can show that f of h by h square f x y a b plus phi 3 h h phi dash psi 2 h h phi dash psi 3 h h, where phi 3 phi psi 2 and psi 3 tending to 0, h h tends to 0. Now taking limit as h tends to 0 from both sides of equation 5 and 6, and since left hand side of equation 5 and left hand side of equation 6 are equal, therefore we get here, if we take the limit h tends to 0 from both sides, therefore this is 0, this is 0, and here also phi is 0, psi 1 is 0, phi 2 is 0, psi 1 is 0, this is 0. Now limit of this is equal to limit of this, therefore limit of uh, phi yx ab is equal to phi xy ab is nothing but, there is no term of h, therefore its limit is nothing but f of yx ab f of xy ab. So both are the equal, f of xy ab is equal to f yx ab. Now this is a approximation where let f of xy is a differentiable function at ab, then approximate value f of a plus h b plus k is approximately equals to f of ab plus h into fx ab plus k into fyab. यावरचे आपण एक्झाम्पल्स बघूया. बाय युझिंग डिफरन्शियल्स फाइंड द अप्रॉक्सिमेट व्हॅल्यू ऑफ 5.12 स्क्वेअर इंटू 6.85. याची अप्रॉक्सिमेट व्हॅल्यू आपल्याला बघायची आहे. 5.12 ला आपण कसं लिहू शकतो, 5 प्लस 0.12. याला आपण ए लिहू शकतो, दिस इज एच. सो 5.12 ला आपण लिहू शकतो ए प्लस एच. सो ए इज अवर 5 अँड एच इज अवर 0.12. सिमिलरली 6.85 ला आपण कसं लिहू शकतो, 6.85 चा मोठा जवळचा नंबर कोणता आहे, 7. 7 मायनस 0.15. 7 ला आपण बी घेऊ शकतो आणि मायनस 0.15 ला के. सो नाव हिअर we can define the function f of xy is nothing but this is our x square and this is our y. So a given function f of xy is nothing but x square y. Find out the f of ab. The f of ab is nothing but a is our 5 and b is our 7. So f of 5 7 is equal to, replace x by 5 y by 7, so 5 square into 7, that is 175. Now fx, derivative of f of xy, f of xy चा derivative with respect to x काय येईल, x square चा derivative 2x, y is a constant, so 2xy. fx at xy is a 2xy. Now fx of 5 7, that is fx of ab is nothing but 2 into 5 into 7, that is 70. Now fy, partial derivative with respect to y is nothing but x square, derivative of y is 1 and x square is a constant. And what is the f of 5 7, just replace x by 5, that is 5 square, that is 25. Now we know that by differential f of a plus h b plus k is approximately equals to f of ab plus h into fx ab plus k into fy ab. So put these values, a plus h is nothing but 5.12, b plus k is nothing but 6.85. So f of 5.12, 6.85 is nothing but f of 5 7 plus h is nothing but 0.12, fx of 5 7 plus k is nothing but minus 0.15, fx of 5 7. Here we replace f of 5 7 is nothing but 175, h is nothing but 0.12, fx of 5 7 we already calculated is 70. Now minus 0.15, that is k, fx, this is nothing but fy, sorry, fy of 5 7 is nothing but 25. Now 5.12 square plus 6.85 is approximately equals to, calculate this, is nothing but 175 plus 8.4 minus 3.75. If you can calculate this, we get 179.65. The approximate value of this is nothing but 170.79.65. Now second example, by using differential find the approximate value of this. We can take this 1.02 is nothing but a plus h, 1.97 is nothing but b plus k. 1.02 is can be written as 1 plus 0.02. We can take 1 as a and h as a 0.02, and a b plus k is nothing but 1.97, that is we can take b as a 2 and k as a minus 0.03. So f of xy is nothing but under root of x square plus y cube. F of 1 2 is nothing but we can take x as a 1, y as a 2. So root of 1 plus 8, this is the root of 9, that is 3. Fx, partial derivative with respect to x, is nothing but 1 upon root 2 चा डेरिव्हेटिव्ह काय असतो, रूट ऑफ एक्स चा डेरिव्हेटिव्ह 1 upon root x. So 1 upon 2, sorry, 1 upon 2 root x. So 1 upon 2 root of x square plus y cube into derivative of 2x, that is derivative of x square, that is 2x, and derivative of y cube is 0 because we have to take derivative with respect to x. So x upon under root of x square plus y cube. Now fx of 1 2 is nothing but 1 upon under root of 1 plus 8, that is 1 by 3. Similarly, what is the fy? Partial derivative with respect to y is nothing but 1 upon 2 root of x square plus y cube into 0 plus 3y cube because derivative of x square is 0. So 3y square upon under root of 2 into x under x square plus y cube. So fy of 1 2 is nothing but 3 into 4 upon under root of 2 into 1 plus 8, that is 12 by 6, that is 2. So by approximation, f of a plus h b plus k is nothing but f of ab plus h into fx ab plus k into fy ab. So it becomes, put this value, all values we get, this approximate value is nothing but 3 plus 0.02 into 13 minus 0.03 into 2. We can calculate 3 plus 0.23 plus minus 0.06, that is nothing but 2.946. This is the approximate value of this. So by using differentials, find the approximate values of this. These are the homework for you. Thank you, students.